Section 13.1, Greatest Common Factor. So in techniques for factoring polynomials, we're going to talk about 5 different techniques. The first one is going to be the greatest common factor, and this will be always the first thing that you're going to look for. And people forget this one because it doesn't always apply, but every time you see the directions that say factor, the first thing you need to do is look for a greatest common factor. Okay, the next one is going to be a 4-term polynomial. If you have a polynomial that has 4 terms, you're going to think factor by grouping. And then if the polynomial has 3 terms, you need to look at, first, is there a greatest common factor? And then, is the leading coefficient 1 or not 1? And then if the polynomial has 2 terms, maybe it's a pattern or greatest common factor. And then you can always check these by multiplying. So since the greatest common factor is the most important one because it is the first one that you're going to look for, we're going to talk about that one first. So the greatest common factor is the largest quantity that is a factor of all the integers or polynomials involved. So to find the greatest common factor of a list of integers or terms, first thing, you're going to write each number or polynomial as a product of prime factors, and you can do this by doing the factor tree. Identify common prime factors, which is why we have the greatest common factor, and then take the product, and product means to multiply, of all common prime factors. If there are no common prime factors, then the greatest common factor is 1. So let's look at this example. So it says find the greatest common factor of each list of numbers. So we have 12 and 8. So we can do a factor tree of 12 and 8. So 2 things that you can multiply together to get 12. I'm going to go with 3 and 4. You can go with 2 and 6 if you want to. Just don't use 1. And then 2 and 2. And then for 8, I can do 2 and 4, and then 2 and 2. So the prime factors are the prime numbers at the bottom of each branch of the tree. So the prime factorization for 12 is 2, 2, and 3. The prime factorization for 8 is 2, 2, and 2. So notice we have 2 2's in common, which are the blue ones, and then we have another pair of 2's in common, which are the red ones. So that's what you're going to do. You're going to find the prime factorization, find any prime factors that are in common with all of your terms, and then you're going to multiply them together. So the greatest common factor of 12 and 8 is 4. So pause the video and see if you can find the prime factorization for 7 and 20. So if we do 7 and 20 with a factor tree, 7 is prime in and of itself, so we don't have to do anything for that. So 7 is going to be 1 and 7. And then for 20, we can do, let's do 4 and 5, and then 4 is going to be 2 and 2. So for 20, the prime factorization is going to be 2 times 2 times 5. Notice there's nothing in common, so the greatest common factor is going to be 1. Okay, so what about these? It says find the greatest common factor of each list of numbers, and we have 6, 8, and 46. So this time we have 3 numbers, but the process is still the same. You're going to do the factor tree for 6, and you're going to do the factor tree for 8, and you'll do the factor tree for 46. So we can do 2 and 3 for 6. For 8, we can do 2, 4, and then 2 and 2. And then for 46, it's going to be 2 and 13 is prime. So for the, 2 and 23, sorry. There we go. So the prime factorization for 6 is 2 and 3. The prime factorization for 8 is 2, 2, and 2. And the prime factorization for 46 is 2 and 23. So the only thing that this list of numbers has in common is 2. So the greatest common factor is 2. So if you have something in common, just write it one time. So pause the video and try 144, 256, and 300. Alright, so for 144, 256, and 300. So 144 I know is 12 and 12, and then I can break that down into 2 and 6 and 2 and 3, and then same thing here, be 2 and 6 and 2 and 3. So the prime factorization for 144 is going to be 2 times 2 times 3 times 2 times 2 times 3. It's all the prime factors at the bottom of your branches. And then for 256, let's see, we can do 16 times 16. And so that's going to be 4 times 4, and that's going to be 2 times 2 and 2 times 2. And then the same thing here, 4 times 4, 2 times 2, and 2 times 2. So the prime factorization for 256 is going to be 1, 2, 3, 4, 5, 6, 7, 8 twos. 8 twos. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay. And for 300, let's go with 30 and 10. So 30 will break down into what? 6 and 5, and 6 will go into 2 and 3, and then 10 will go into 2 and 5. So we have, for 300, we have 2 times 3 times 5 times 2 times 5. Okay, so for our greatest common factor, we need to figure out what's in common. So we have 2's in common, and we have another 2 in common, and I think that's it. So the greatest common factor here is going to be 4. Alright, so let's try some with variables. So with the variables, we have x to the third and x to the 7th. So again, you list out the prime factorization for each one. So x to the third, basically with the variables, you're just writing the meaning of it. X to the third is x times x times x. X to the 7th is 7 x's out there. And so now we've got to figure out what's in common. So the greatest common factor, they have 3 x's in common. And so x times x times x is going to be x to the third. So pause the video and see if you can do the greatest common factor for 6x to the 5th and 4x to the 3rd. So for the 6th, we have 2 and 3. And for the x to the 5th, we have 5 x's. So let's just go over here. I don't need a factor tree for that. We have 2 times 3 times 1, 2, 3, 4, 5. And for 4x to the 3rd, we have 2 times 2 times 1, 2, 3. So for the greatest common factor, notice that the numbers have a greatest common factor of 2, so 2's in common, and then they have 3 x's that are in common. So the greatest common factor is going to be 2x to the 3rd. Okay, so let's try this one. Pause the video and see if you can find the greatest common factor for these three terms. So for a to the 3rd b squared, we have 3a's and 2b's. For a squared b 5, we have 2a's and 5b's. For a 4b 7, we have 4a's and 7 b's. Okay, so for the greatest common factor, let's see how many a's are in common. I have 1, 2, and that's all the a's in common, so I have a times a. And for the b's, I have 1, 2 in common as well. So b times b. So the greatest common factor is going to be a squared b squared. Now, if you don't want to write down all of these variables, a helpful hint is this. Remember that the greatest common factor of a list of terms contains the smallest exponent on each common variable. So for example, the greatest common factor of x to the third, y to the fifth, and x to the sixth, y to the fourth, and x to the fourth, y to the sixth is going to be the smallest exponent for your x's and the smallest exponent for your y's. So you have x to the third and y to the fourth. So again, if you don't want to write out all the common or all the factors of your variables, you don't have to. But for your numbers, you need to. For your coefficients, you need to. But for your variables, if you want to just remember this little hint, that will be fine too. Okay, so let's actually get into factoring some polynomials. The first step in factoring a polynomial is to find the greatest common factor of all its terms. And remember, that is your first step. Then we write the polynomial as a product. So we're going to turn a polynomial into a multiplication problem, which means you're going to be using parentheses. By factoring out the greatest common factor for all the terms, and then the remaining factors in each term, will form a polynomial. Okay, so here we have a trinomial. I know it's a trinomial because I have 1, 2, 3 terms, and tri is the Latin prefix for 3. So I have trinomial. What I want to do is I want to find what's in common between 6, 9, and 12. So in other words, what is the greatest common factor? You can use the factor tree if you need to find the biggest number that will go into 6, 9, and 12. And I think that's going to be 3. And then I need to find the greatest common factor for my variables. And if you remember the hint says that you're going to go with the smallest exponent. Well, this has a 1 here. So the greatest common factor would be 3x. Now, once you have your greatest common factor of your terms, what you're going to do is you're going to write the greatest common factor on the outside, and then you're going to have a set of parentheses on the inside. So what I'm going to do is I'm going to divide a 3x out of each one of these. So we can go back to what we did in pre-algebra and divide each one of these by that common factor. So 6x to the third divided by 3x is going to be 2x squared. And then remember, the sign in front of the number goes with that number, so we have minus. 9 divided by 3 is going to be 3. X squared divided by x is going to be x. Sign in front of the number goes with that number. And then 12x divided by 3x is going to be simply 4 because the x's cancel out. So you try number 2. Alright, so let's see how we did. So the greatest common factor between 14, 7, and 7 is going to be 7. The greatest common factor between the x's is going to be the smallest x term, or smallest x exponent, and then for the y is going to be the smallest y exponent. Alright, so once we do that, if we take a 7xy out of that first term of 14x to the third y, 14 divided by 7 is going to be 2. And then x to the third divided by x is going to be x squared, and the y's cancel out. So sign in front of the number goes with that number. And if we divide a 7xy out of 7x squared y, that's going to give us just 1x. And then if we do negative 7xy divided by 7xy, we're going to get simply a negative 1. And if you need to write it like this, like I did in the previous problem, to help you see what we're doing, that's fine. Just remember, when things divide out, they divide out to 1. Alright, so factor out the greatest common factor in each of the following polynomials. Now, the difference in what we just did and now is we actually have groups. So here we have terms, okay, so a term is an indicated product. So this actual polynomial is a binomial. It has 2 terms, and those terms are separated by the subtraction sign. So the term on the left is 6x plus 2, 6 times x plus 2. And the term on the right is y times x plus 2. So we have 2 terms. Can you look at these 2 terms and see what's in common? Well, if you write it like this, you would be able to see that the 2 terms that are in common are the ones in blue, and it just so happens to be the binomial. So, same thing, greatest common factor. Both of them have a common factor of x plus 2. Factors are things that you multiply together. So what I'm going to do is I'm going to factor out the greatest common factor of that x plus 2. And then what's going to be left out, because if I divide here by x plus 2, the x plus 2 cancel out, leaving me with the 6, and it goes here. If I divide this term by x plus 2, that cancels out, leaving me with the negative y, and that goes there. So see if you can figure out how to do number 2. Okay, so again we have two terms. We have xy times y plus 3, that's one term, minus this other term. And there is a coefficient of 1 there. So if that helps, go ahead and write that too. So we have a two-term polynomial, 1, 2, which means in our answer we need a two-term polynomial. We're going to have some binomials. Now, this y plus 1 is what's in common, so we're going to factor it out front. And then what's left out of the first term is going to be xy, and what's left out of the second term is a minus 1. So that's what you should have gotten. So now that we've talked about greatest common factor, we can talk about all of the other factoring techniques. So the first one we're going to talk about, or the next one we're going to talk about, is factor by grouping. When you think of factor by grouping, you need to see a 4-term polynomial. So anytime you see a 4-term polynomial, you need to think grouping. Okay, so step number 1, you're going to group the terms in 2 groups so that each group has a common factor. Step number 2, factor out the greatest common factor from each group. Step number 3, if there is a common binomial factor, factor it out. If not, rearrange the terms and try these steps again. Now what I like doing is I like to just keep my terms in the same order initially and try that, and then if that doesn't work, then I'll go back and reorder. So what I'm going to do is I'm going to keep my problem the exact same, and I'm going to group the first 2 terms plus the last 2 terms. So when I do that, what I'm going to do is I'm going to factor out the greatest common factor in the first group, and then I'm going to factor out the greatest common factor in the second group. So the greatest common factor between 15x to the third minus 10x squared is going to be a 5, because a 5 will go into both 10 and 15, and then x squared. So if I take 5x squared out of 15x cubed, I get 3x. And if I divide a 10x squared by 5x squared, I just get negative 2. And again, this is what we're doing. We're dividing each term by that greatest common factor. So 15 divided by 5 is 3, x to the third divided by x squared is x. Minus, sign in front of the number goes with that number. 10 divided by 5 is 2, and x squared divided by x squared, that goes to 1, cancels out. So let's go to this one. The greatest common factor between 6x and 4 is just 2. So if I divide 6x by 2, I get 3x. And if I divide negative 4 by 2, I get negative 2. Now this takes us back to the previous problem on the previous page. We have 3x squared and 3x minus 2 and 3x minus 2. That is your common binomial factor between the 2 terms. So we're going to factor that out front, and then what's left over, the 5x squared and the 2, go in the second set of groupings. So when you factor by grouping, your answer should be a binomial times a binomial, and you should be able to do full on that to check and make sure you got it right. Okay, so let's try this one. Let's walk through this one. So let's group the first 2 and the last 2 together. So in the first one, the only thing I have in common is an a. So if I factor an a out, I'm going to have 2a plus 5b. Well, look at that second group. I already have 2a plus 5b. So all I'm going to factor out is a 1, and I'll have 2a plus 5b. So I can factor a 1 out of anything and it's not going to change. So now I have common factors of 2a plus 5b, and I'm going to factor that out front. And then I have a common factor, or what's left over, which is going to be an a plus 1, and that's factor by grouping. So group the first two, and then group the last two, factor out the common factor in the first group, factor out the common factor in the second group, and you always have a common factor of 1 if you can't find another one. And then you should have identical binomials. If you do this process correctly, these binomials will always be the same. So what you're going to do is you're going to factor out that common binomial as your new greatest common factor. And then whatever is left over when you factor out the common binomial is what goes in that second group. So let's look at this problem. Notice if I group the first two and the last two, notice that there's not going to be anything in common. So we need to rearrange these. So what I'm going to do is I'm going to put the 3's together. And then I'm going to put the y's together, or the 2's together, but I'm going to put them in descending order. So I'm going to have a negative 2y plus 2. So now what I'm going to do is I'm going to group the first and I'm going to group the last. So what happens is when you rewrite this, you'll have 3xy minus 3x. You need that plus sign in there. Minus 2y plus 2. So now let's factor out what's in common. In the first group, there's going to be a 3x in common. And so I'll factor that out and I'll get y minus 1. In the second group, there is a 2 in common, but notice that leading coefficient's negative and we don't want that. So let's factor out a negative 2. And when I do, that's going to change my sign. So that's going to change that first term from negative to positive. And that's going to change that second term from positive to negative. And then 2 divided by 2, of course, is 1. Now I have common binomials, and so I'll have y minus 1 times 3x minus 2. Alright, so let's look at this one. For this one, I'm going to have, let's try just grouping the way it is and see what happens. So the greatest common factor in the first two, I'm thinking is going to be 3, because 3 will both go into 21 and 9. And then for x, I'm going to have an x squared. And for my y, I'm just going to have a y. Remember, we're going with the smallest term. So 21 divided by 3 is going to be 7. X to the third divided by x squared is going to be x. And then x squared divided by, y squared divided by y is going to be y. Minus 9 divided by 3 is going to be 3. And then x squared y divided by x squared y, that cancels out to 1. Alright, out of the second group, I think if I factor out a 2, and that is going to be the greatest common factor, I'm going to have 14 divided by 2 is going to be 7xy, and negative 6 divided by 2 is going to be negative 3. So that gives me my common binomial that I'm going to factor out, and that's going to leave me with the 3x squared y plus 2.